Earlier this year, Astra failed to reach orbit during the TROPICS mission with NASA when the upper stage shut down early due to a higher than normal fuel consumption rate. This marked the fifth failure with the Rocket 3 line, and soon after, Astra announced it would be moving on to Rocket 4. Since that update, the company had kept quiet in regard to details about this new launch system. Thankfully, just a couple of days ago on the 7th, Astra released a bunch of new information on Rocket 4, including its design, purpose, expected launch date, and more. Not to mention, the company also went in depth into what Astra's future would look like, and how they plan to turn things around. This included a completely reinvented process of launching and supporting missions. While Astra Space had a strong start and became the fastest company to reach orbit, this momentum recently came to a jarring halt. A pattern the company is dedicated to fixing in the coming years, starting with Launch System 2.0. Here I will go more in depth into Astra's new Rocket 4 announcement, additional details about Launch System 2.0, what to expect in the future, and more. Earlier this week on the 7th, Astra tweeted saying, "Welcome to Launch System 2. Here the company released new reports and videos regarding both Rocket 4 and the general Launch System 2.0. Focusing on the new rocket first, Astra highlighted that Rocket 4 builds on the heritage, flight-proven designs, and manufacturing techniques of hundreds of subsystems demonstrated during the successful orbital flights of the 3 series rockets, but there are several key changes to the Rocket 4 architecture. The first has to do with increased size and capacity. Rocket 4 will stand 62 feet from tip to tail, with a total diameter of 72 inches. The overall size increase allows the vehicle to carry greater volumes of propellant, and in turn, deploy significantly more payload mass, with a target payload capacity of 600 kilograms to mid-inclination 500 kilometer low Earth orbit over the course of the product lifecycle. In comparison, Rocket 3, which we have seen lift off multiple times now, stood just 38 feet tall with a payload capacity ranging from 25 to 150 kilograms. The next change is an increased fairing size. Rocket 4's increased diameter provides a dramatic increase in the volume available for Astra's customer spacecraft. This increased fairing was designed to fit one ESPA large spacecraft, 2 ESPA spacecraft, or multiple CubeSats, with a maximum height of 133 inches and a maximum width of 67.5 inches. As for the booster, Astra points out that Rocket 4's first stage architecture uses much of the same designs from Rocket 3.3, with 2 key updates that will dramatically improve performance and manufacturability. First, the domes are now stamped directly from single sheets of aluminum, reducing weight and streamlining overall manufacturability, which in turn reduces launch costs for their customers. Second, the first stage engine architecture has been simplified from 5 battery pump-fed engines to 2 turbo pump-fed engines, and will deliver approximately 80,000 pound-force of thrust at liftoff. Astra is developing and qualifying an upgraded derivative of a previously qualified engine for this application. Just a few months ago in the beginning of September, Astra tweeted mentioning, "Testing engines for our new launch system." Here the company provided a 25-second video of the new engine firing. Since then, Astra has continued to test the new and more powerful engine in preparation for its application on this new launch vehicle. Moving up the rocket, Astra Space points out that the upper stage has undergone the largest architectural change from Rocket 3.3. Rocket 4's upper stage has moved to a full-diameter common dome design, which aligns production approaches between the 2 stages, increasing build reliability and decreasing total manufacturing costs. The upper stage is propelled by a turbopump-fed liquid oxygen/kerosene engine delivering around 6,500 pound-force of vacuum thrust. This engine is also a derivative of an existing qualified engine, all of which is expected to be put to the test for the first time with an initial test flight in 2023. This was confirmed by the company just days ago during the update. While a specific date or time frame was not provided within 2023, if Astra works quickly, it's possible this flight happens toward the very end of that year. Now that we know more about Astra's new Rocket 4 and what improvements have been made over the previous launch vehicle, we can take a closer look at Astra's plan and a few other big changes the company is making. Astra believes a reliable launch system is about much more than just a rocket. It's about creating an integrated system that works seamlessly together. The launch system is comprised of 3 key subsystems: the rocket, ground systems, and mission control. Starting with the ground systems, one of Astra's core values is simple scales, and that is reflected in the goal to develop an easy-to-deploy mobile launch system. The ground system has undergone several impactful updates that simplify the system and support scaled launch operations. First, it was optimized for improved site turnaround. Critical systems have been moved from the launcher into 2 easy-to-access containers on the launch site, shielding critical components and simplifying maintenance between launches. Second, it has been designed for mobility. Despite the overall size increase of the rocket, the launcher and rocket are still designed to fit within standard-sized shipping containers. ensuring that Astra's launch system remains easy to deploy by land, sea, or air. Lastly, it will be designed for automation. Launch System 2 uses sensors and valves that can detect issues and report back to launch operators in real time, flagging anomalies in the system and mitigating issues through early detection. Moving on to mission control, Launch System 2 provides Astra an opportunity to further improve the interface between its launch operations team and the launch system's hardware. Key updates being made to mission control include increased automation through software improvements to eliminate more opportunities for human error, creating a more scalable and reliable launch system. In addition, they are working to simplify pre-launch procedures to reduce the number of mission control operators. The end goal for Launch System 2 is to reduce the number of mission control operators from 4 to 2. Simplified procedures and increased automation will effectively double Astra's mission control teams with no additional headcount, reducing launch costs for customers. Astra's goal with Launch System 1 was to achieve orbital capability as quickly as possible and demonstrate that they could mass-produce rockets. However, following the flight anomaly on their last launch, Astra said, "We listened to our customers, our team, and our stockholders, and made the strategic decision to accelerate the introduction of a higher performance rocket, and add additional testing that we believe will increase the reliability of future launches." Launch System 2 is the company's answer to their existing launch customers, and an increasing number of satellite operators around the world that need affordable and frequent dedicated orbital launch services to enable new space services. While Launch System 1 made Astra the fastest privately funded US company to reach orbit, the goal of Launch System 2 is to build a highly reliable system that they believe can scale to a weekly launch cadence. The new launch system not only builds on the heritage of Launch System 1, but it also represents a cultural shift from Astra's primary focus on schedule to a focus on reliability. This launch system is a result of a significant change in how Astra designs, builds, qualifies, and operates its launch system. Launch System 1 began its initial development with just a handful of people in a garage 6 years ago. Launch System 2 is being designed by teams of world-class engineers in a 225,000 square foot manufacturing and testing facility. Astra highlighted that they are a completely different company than when they designed Launch System 1, and that shows in the level of investment they're making into the reliability of this system. The entire system has been scrutinized and re-engineered where necessary to support Astra's plans to reliably and repeatedly deliver their customers' payloads to orbit. Astra finished by mentioning, "We expect Launch System 2 to deliver best-in-class launch economics and launch frequency via a platform that is being optimized for reliability at every phase of the development process. It's an incredibly exciting time to be bringing this new launch system to the market, which we have designed from the ground up to deliver the launch services that we understand our customers need." Astra Space has had many ups and downs in a short period of time. After becoming the fastest company to reach orbit with Rocket 3, the company decided to cancel that line and move on after a fifth failure. Just a few days ago, Astra released new information on not only its new rocket, but also how they plan to evolve Astra's goal and purpose within the industry. We will have to wait and see how it progresses and the impact it has on the space industry. Thank you very much for watching.